A blessed morning, learners! As we have reached the test hypothesis lesson, we prepare an activity that would sharpen our skills in the statistics and probability subject. Thus, in today's presentation, we are going to solve, interpret, and draw conclusions from the 5 given information. With that being said, let's proceed to answer the first item. The null and alternative hypothesis are both given in this situation. The null hypothesis is equal to 80, while the alternative hypothesis is not equal to 80. First, let us all list down the following given, for it will be much easier for us to draw the conclusions from it. In this item, we have the population mean, which is equal to 80. The sample mean is equal to 83. 39 is the sample size, and the standard deviation here is 5. Then, we are going to use 0.05 or 5% as the level of significance. If we are going to look at the symbol used in our alternative hypothesis, we will know that this is an example of a two-tailed test because of the symbol not equal. Then, let's take a look at the given sample size. Since 39 is greater than 30 and the standard deviation is known, we are going to use the C-test in computing the computed value. This is the formula for the C-test. Let's substitute the given and we will get 3.747. Again, since we are using a 0.05 level of significance and it is a two-tailed test, our critical value or the boundary between the acceptance and rejection region is equal to positive and negative 1.916. Then here is our hypothesis test graph. As we can see in the graph, the computed value is lying in the rejection region. We can now conclude that since the 3.747 computed value is greater than the absolute value of our critical value, which is 1.960, then that means there is a sufficient evidence to reject the null hypothesis and favor the alternative hypothesis.
In given number 2, the null hypothesis representing the population mean is equal to 7.5, while the alternative hypothesis is greater than 7.5. The sample mean is 8.3 and the standard deviation is 3.17 and 52 is the sample mean. This is a one-tailed and right-tailed test. Using the formula, we substitute all the given values. 8.3 minus 7.5 divided by 3.17 over square root of 52. Using calculator, we will take the 3 decimals. The total is 1.820 and the critical value is 2.326. When we graph it, the right-tailed test is the rejection region. If our computed value is higher than the critical value, we will reject it. In the left-tailed test, when the critical value is higher than the computed value, we will not reject it because the left-tailed test is a non-rejection region. Our computed z-value is 1.820, which is less than to our critical value of 2.326. Therefore, we fail to reject the null hypothesis.
Let's move on to the third item. The same step as the previous items, let's list down the following given. The population mean is equal to 10, the sample mean is 15, the sample standard deviation is 6.1, while the sample size is 9. Then, we are going to use 0.01 as the level of significance since our alternative hypothesis here has a greater than symbol. We can say that this is an example of a one-tailed test, specifically a right-tailed test. Since the sample size is small and the standard deviation is unknown, we are going to use the t-test in computing the computed value. Using the formula, we just substitute all the given values, 15 minus 10, and divided by 6.1 over the square root of 9. We will get 2.459. On the other hand, use your T table and look for the 0.01 level of significance of a one-tailed test with 8 as a degree of freedom. Then we will get 1.860. If we are going to construct a graphical representation, as we can see, the rejection part is found at the right part of the graph with a critical value of 1.860. Since the computed value is lying on the left part of the graph, that means it is in the acceptance region. Finally, our conclusion will be that since the 2.459 computed value is greater than the critical value, which is 1.860, therefore there is sufficient evidence to reject the null hypothesis because it is in the non-acceptance region. So, we will support the alternative hypothesis.
For the fourth item, our null hypothesis is equal to 116.12 while the alternative is greater than 116.12. Now, our given will be like this. The population mean is equal to 116.12. The sample mean is 118.7, while 21 is the sample size and the standard deviation is 7.18. Also, our level of significance in this item will be 0.01. Then the sample size is 21. Since the alternative hypothesis is greater than, again, we use the right tail test. Since the sample size is small, but the population follow a normal distribution with a standard deviation of 7.18, meaning to say the population standard deviation is known. Therefore, we are going to use the C-test formula. Substitute all the given, that will be 118.7 minus 116.12 divided by 7.18 over 21. Then we will have 1.67 as the C value. In getting the critical value, look for the right tail test with a 0.01 level of significance in the C table. Then we will have 2.326, so the computed value is 1.647, and then the critical value is 2.326. If we graph it, we can conclude now that since the 1.647 computed value is less than the critical value, which is 2.326, therefore we will fail to reject the null hypothesis because it is in the acceptance regions.
For the last item to solve, we have the null hypothesis, which would also be our population mean, which is 215, and the alternative hypothesis is not equal to 215. Again, list down the given. We have the sample mean, which is equal to 219.3, a sample standard deviation 13.12, and a sample size, which is 21. Since the sample size is small and the population standard deviation is unknown, we are to use this formula in getting the t value. Again, substitute all the given and using the calculator, we will get 1.537. Then in order to find the critical value, use the t-table and find the intersection of two-tailed tests with a 0.01 level of significance and the degrees of freedom, which is 20. So, our critical value now would be positive and negative 2.080. Finally, we can now conclude that since the 1.537 computed value is less than the absolute value of critical value, which is 2.080, therefore, there is no sufficient evidence to reject the null hypothesis since it is in the acceptance region. So, we will support the null hypothesis. That concludes our presentation for today, learners. Thank you for watching.